In question 7, we have a diagram AOB, which is a quarter circle with center O and radius R. The point C lies on the arc AB and the point D lies on OB. The line CD is parallel to AO and angle AOC is theta radians. We have to express the perimeter of the shaded region in terms of R, theta, and pi. Now, the perimeter of the shaded region we can see is given by three regions. So one of them is the length BD plus the length of CD plus the length or the arc BC. So in the first step, what we can do is we know that this is a complete angle is a right angle and this is theta. So this will be 90 minus theta. One of the identities that we must remember is that the sine of theta is equals to cos of 90 minus theta, or we can also write it the other way around, which is cos of theta is equals to sine of 90 minus theta. So we need to first find the length of CD. To find the length of BD, we will find the length of OD. And as this is a radius AO, which means OB is also a radius. So we'll subtract the length of OD to get the length of BD. And then we'll apply the arc length formula to find the length of BC. So in the first step, finding the length of DC, we know that this is opposite. So let's say this is X and hypotenuse is R. So we can write sine of 90 minus theta is equals to the length CD upon R. So CD will be is equals to R times sine of 90 minus theta. Now we know that sine of 90 minus theta can be written as cos theta. So this will CD will be R of cos theta, R times cos theta. Now finding the length of OD, we can apply. So let's write Y up here. So OD will be is equals to, we can apply adjacent over hypotenuse. So cos of 90 minus theta will be is equals to Y upon the radius R. So the Y will be is equals to R times cos of 90 minus theta. As we know that cos of 90 minus theta can be written as sine theta. So we can write that Y, which is OD, is equals to R sine of theta. Now the length of BD will be is equals to, BD will be R minus R sine theta. And finally, to find the arc length BC, so we'll use the arc length formula. So arc length of BC will be given by the formula S equals to R theta. So radius is R and theta is 90 minus theta. Now adding these three lengths, so we have the length of CD, we have the length of BD and the arc length. So the perimeter will be is equals to R cos theta plus R minus R sine theta plus R into 90 minus theta. As it is in terms of radians, so we will, instead of 90, we will use 1 upon 2 pi, as we have to give our answer in terms of radians. So this will be R of 1 upon 2 pi minus theta.